Your graphs may not have, you may not have the graphing coordinate plane on this example. So, but let's still go through all the steps so that we can remember how to graph. So the first thing you want to do is identify the base of your exponent. You're going to use that. You can go ahead. You're going to use that to create your parent table. So let's go ahead and make our parent table. So these are our numbers. So pick up your calculator. Type in 2 to the power of -1. 2 to the power of 0. 2 to the power of 1. 2 to the power of 2. And 2 to the power of 3. That's what an exponential function is. It simply means that our exponent is changing. We have a changing exponent. Okay. So 2 to the power of -1 would be 0.5. 2 to the power of 0. Anything to the power of 0 is 1. 2 to the first is 2. 2 to the second is 4. And 2 to the third is 8. So that's my parent table. So now looking at our equation, let's find A, H, and K. So remember, A is always the number in front of the base, so we have an invisible 1. H is going to be found in your exponent, but remember, H is always opposite. So instead of H being a +3, what is H going to be? A -3. So that means it's going to move our graph to the left 3. And then our K value is in the back. K is -1. So remember, for an exponential, the K value is the MVP, because that number is going to tell us two things, very important. It's going to tell us our range and our horizontal asymptote. That's what HA is, by the way. HA is my abbreviation for horizontal asymptote. So let's go ahead and find our new function table. So as you know, you always take the H and add it to X. So H is -3. So pick up your calculator and add -3 all the way down. On the Y side, you're multiplying it by 1 and subtracting 1. But we all know that multiplying something by 1 has no effect, so we're really just subtracting 1. So I'm going to give you a couple minutes. Pick up your calculators and find your new table. So using your calculator, you're going to add -3 to all your X values and subtract 1 to all of your Y values. So I'll give you a couple seconds to do that. So when you do that for your X values, you should get -4, -3, -2, -1, and 0. And on your Y side, when you subtract, you should get -0.5, 0, 1, 3, and 7. Now, the domain for all exponential function does not change. Does anybody remember what the domain was for every single exponential function? Never changes, ever. No matter what A, H, and K are. All real numbers, you're right. So let's go ahead and write that. We have all real numbers. Now remember, I told you that K is the MVP, because K is going to tell us two things. It's going to tell us our range and where our horizontal asymptote is. So because K is -1, we have a horizontal asymptote at -1. Now I realize you all don't have a graph, so I'm just going to sketch it and you can see what it looks like. Horizontal means you have it's an invisible line on the graph that is a boundary. The graph will never cross it or touch it. And if you look at our y values that we came up with over here, all of these numbers are greater than -1. So your range will be y is greater than k, which is -1. It's never going to equal k, but it's going to get really close. So your sketch, and I'll just do a quick sketch. Feel free to make a sketch as well. Just make your own graph. So when you do that, this is what it should look like. So that is what your graph would look like if you were asked to graph it. So in your notes, go to page 9. Today we're going to learn something new, and that's how to solve an exponential equation. How to solve an exponential equation. So go to page 9 in your notes. Now, the key for an exponential equation is you have to write the expression with the same base. And the reason why we're doing that is so we can drop the base. If the bases are the same, then we can drop it. And when we drop it, we can set the new exponents equal to each other. And after we do that, we can solve for x. So the key here for an exponential equation is finding the same base so you can drop it. And then you can set your exponents equal to each other and solve for x. So let's look at question A. Notice that for question A, we already have the same base. So that means we can drop them. And let's set our exponents equal to each other. So let's do that. That will give us x plus 1 equals 2x minus 3. So this 2x needs to be moved to the left. It's positive, so how am I going to do that? Am I going to add it or subtract it or multiply it or divide it? Which one? Subtract it. Good. So let's subtract that 2x from both sides. And then that's going to give us negative 1x plus 1 equals negative 3. All right, so now we need to move this plus 1 to the right. It's positive, so we will subtract it. So that would be negative 1x equals negative 4. And then your last step would be to divide, because that negative 1 is being multiplied. And who remembers what a negative divided by a negative will give us? What's a negative divided by a negative? Is it positive or is it negative? Positive, positive 4. And that would be your answer. So that was a pretty easy one because we already had the same base. But I can guarantee you on the test, you will not have the same base. So we're going to have to find our common base. So let's look at question B. So notice that we don't have a common base. So what you want to do is look at the smaller number, the smaller base, and see if you can get to the bigger number or the bigger base by changing the exponent. So for example, I'm going to look at that base 2. What is 2 to the power of 1? 2 to the power of 1 is 2. What is 2 to the power of 2? 4. So ding, 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 ding. There we go. So we know that we can rewrite the 4 as 2 squared. So let's do that. Let's write the 4 as 2 squared. Bring down the x that was there. See how there was an x? That comes down. And set that equal to the right. So now we have a common base, so we can drop it. And that's going to leave us with 2x equals x plus 4. Now this x that's on the right needs to come over. And how do I do that? Would I add x or would I subtract the x? Subtract. So 2 minus 1 is 1. So we end up with x equals 4, and that would be our answer. So again, the name of the game is find the common base. All right, let's look at question C. So again, we have two different bases. So the first thing you're going to do is use the smaller number to see if you can get to the bigger number. So pick up your calculators and let's try a couple of these exponents on 4. See if any of these options will give us 64. So type in 4 to the power of 2, 4 to the power of 3, 4 to the power of 4. Will any of those give us 64? 4 to the power of 3, who found that? Raise your hand if you got 4 to the power of 3 is 64. All right, so that's it. Because 4 to the power of 3 is 64, then I can rewrite this as 4 to the power of 3. Bring down the x minus 3 that was there, but put it in parentheses. And you're going to set it equal to 4 to the power of x plus 3. Now we have our common base. So we can drop it. So that gives me x plus 3 equals 3 times x minus 3. So we got to distribute this 3. So everything on the right that's on the inside of the parentheses, multiply it by 3. So that gives us x plus 3. And then that's 3x minus 9. All right, so now this needs to move over. And how do we do that? It's positive, so we're going to subtract it. One minus 3 is negative 2x. Bring down the plus 3, and that equals negative 9. All right, now this plus 3, we need to bring that over. And how do we do that? Subtract it, because it's positive. All right, so go ahead, pick up your calculators and find out negative 9 minus 3. Negative 9 minus 3. What does that give you? Negative 12. And then our last step is to divide both sides by negative 2. And the negative divided by a negative is positive. So my final answer would be x equals positive 6. Because if we have the same base, we can drop the base.
And then it will automatically just be an x?
Right. Okay. You always drop the base, see if you can get the common base so you can drop it.
Will the base ever be different numbers?
No, you have to get the same base. You have to get the same base. Now, I realize that D appears twice, so we're going to skip this question D for now. Go to the next row. And then we're going to do E and then this question D. All right, so again, I'm going to come back to that one because that's the hardest one. So again, look at the smaller base to see if you can get to the bigger base. So I have a 2. How many times do I multiply 2? 2 to what power is going to give me 8? Show me with your fingers. What do you think my exponent is going to be? Andre, what you think it is? Let's try it out. So take 2 to the first, 2 to the second, and we all agree that it's 2 to the third. So we're going to rewrite this 8 as 2 to the power of 3. Yep. So we're going to rewrite that as 2 to the power of 3. Now this exponent that was there, we're bringing it down and putting it in parentheses. So we have our common base. So now that it's the same base, it has to be the same base. That's why I couldn't drop it in the beginning, because they weren't the same. They were different. One side was an 8 and the other side was a 2. But now both sides are 2. So we can drop the 2's. And we're setting these exponents equal to each other. All right, so we have 3 times 2x plus 3 equals x minus 5. Now let's multiply. Multiply the 3, multiply the 3. So that would be 6x plus 9 equals x minus 5. So any x that you see on the right, we need to move over. And that's a positive x, so in order to do that, we're going to subtract it. Six minus 1 is 5. All right, now we have a positive 9 that we need to move over. We have to move that to the right. And what's the opposite of addition? Subtraction, good. So let's subtract the 9. All right, go ahead and pick up your calculators. Figure out what you get when you take negative 5 minus 9. Negative 14. Who agrees that it's negative 14? All right, and then our last step would be to divide both sides by 5. So we are going to get a fraction or a decimal. I would probably leave it as a fraction, but I think most of you all would make it a decimal. So what do you get when you divide negative 14 by 5? Negative 2.8. So I would take either one of those for full credit. Any questions? Thumbs up, sideways, down. Where we at? All right, we just got 2 more. So can I get to 25 with a base 5? 5 to the what power is going to give me 25? Show me with your fingers. What do you think? What's the exponent going to be? 2. Yep, you got it. So right here, I'm changing this to 5 squared. Bring down that 2x plus 1. Keep that in parentheses. All right, now we can drop the 5. So that gives us 3x minus 1 equals 2 times 2x plus 1. All right, so let's multiply this 2. 2 times 2 and 2 times 1. What do you get when you distribute that 2? What's 2 times 2x plus 1 going to give you? What were you saying, Danny? Yep, 4 what? 4x plus what? You got to multiply, so it'll be 2. Yep. So now we're going to take this and subtract that over. So let's subtract the 4x. Oops, wrong side. All right, so 3 minus 4 would give you a negative 1x minus 1 equals 2. Any ideas what my next step is going to be? Add 1 to both sides. So negative 1x equals 3. And then our last step would be to divide both sides by negative 1. So your final answer is x equals negative 3. Any questions? So now let's go back to the one I skipped. The reason why I skipped it is because that's the only example where we have to change both sides. So when I'm looking at this example, if I look at my smaller number 9, there isn't an exponent that I can put on 9 to get to 27. 9 to the first is 9, and 9 to the second is 81. So that means that both sides need to go down to a lower number. So don't say it out loud, but I want you to show me with your fingers what base you think I'm going to use. Just curious. I agree. It's a base 3. Good job. So we know that 3 to the power of 2 is 9. So that means I'm going to change this to 3 to the power of 2. Bring down that 3x plus 1. And then we also know that 3 to the power of 3 is 27. So I'm going to change this to 3 to the power of 3. So both sides of my equation had to get a new base. So we're going to drop the base. That leaves me with 2 times 3x plus 1 equals 3 times 3x minus 4. So pick up your calculators and multiply. You're multiplying the left side by 2 and the right side by 3. That's your first step, because you have to get rid of the parentheses. So 2 times 3 is 6. And 2 times 1 is 2. That equals 3 times 3, which is 9. And 3 times 4, which is negative 12. So we're going to bring this 9 over. It's positive. So go ahead and subtract the 9x. So 6 minus 9 would be negative 3x plus 2 equals negative 12. Now we're ready to move this plus 2. Subtract 2 from both sides. So that gives us negative 3x equals negative 14. And then our last step would be to divide by negative 3. So again, we get another decimal. So x equals, you can leave it as positive 14 thirds. Or what is that if you type it in your calculator? What do you get as a decimal? Any ideas? What'd you say? 4.67. All right, so now let's look at homework 2, which you all picked up. Homework 2 is due Wednesday. Homework 1 is due today. But if you look at homework 2, there is one question. I want to do the hardest exponential one, and that's number 4. So let's all look at question 4 together, because this is the only example where you have to change both sides. You don't have to change both sides on any of the other questions. So I'm just going to get you started and let you all finish it. So what is my common base? Because I can't use 25. If I take 25 to the power 2, I don't get 125. So that means both sides has to go down. So show me with your fingers. What do you think my base is going to be on both sides? Yes, 5. Good job. So 5 to the power of 3 is 125. So that's what I'm going to change this side to. Make sure you put that 3x minus 4 in parentheses. And then we know that 5 to the power of 2 is 25. And put that 4x plus 2 in parentheses. Now you can drop the base. And this is what you have. This is what you need to solve. So you're going to distribute the 3 on the left and distribute the 2 on the right. Go ahead and solve this for x. And after you're finished with that, I want you to work on numbers 1, 2, and 3 on the front. And on the back, 11, 12, and 13.